Hello and welcome everyone to today's lecture of the Life Theory Lab. My name is Miriam Sander and together with Thorsten Pachur, I am the moderator of today's session. The Life Theory Lab has been organized by Markus Werkle-Bergner, Ulman Lindenberger and Imke Kruse and is part of the educational program of the Life Graduate School. Today's talk will be about 45 minutes and there will be time for questions afterwards. And we have one tradition in the live program that is fellows first. So the first questions are open for the fellows, and afterwards we will open the round to the general audience. Please use the little sign of a question mark if you want to ask a question, and Thorsten will collect all these questions and we will then call you when it's your turn. I would also like to remind you that the session is recorded. So if you don't want to hear your voice or have your voice recorded or hear it on YouTube later on, then just don't ask a question or only send it to Thorsten and then he can ask a question for you. And also for all the live fellows who are like panelists of this session, please remember to mute your microphone during the talk. And there's one other tradition of the Life School, that is that one of the fellows is introducing the speaker, and today this is Andrea Hasel from University Potsdam, who will introduce Candice Odgers. So Andrea, it's your turn.
Okay, so thank you very much. Hello to everyone. I am Andrea Hasel, a Life Fellow from the Berlin site, and I have the honor to introduce Professor Candice Odgers. So, Candice Odgers received her PhD at the University of Virginia in 2005 and is a professor of psychological science at the University of California, Irvine, and a professor of public policy, psychology, and neuroscience at Duke University. Her research focuses on how social inequalities and early adversity influence children's future health and well-being, with an emphasis on how new technologies, including mobile phones and web-based tools, can be used to understand and improve the lives of young people. Professor Odgers was a William T. Grant Scholar and the recipient of early career awards from the American Psychological Association, the Society for Research and Child Development, the Royal Society of Canada, and the Association for Psychological Science. In 2015, she was awarded the Distinguished Contributions to Psychology in the Public Interest Early Career Award, and in 2016, the Jacobs Foundation Advanced Research Fellowship. And we are honored to have Candice Odgers with us here today, and we're looking forward to your talk. Thank you.
Thanks, Andrea. So Candice, it's all yours now.
Okay, thank you. I will start my timer. I know everyone has been on Zoom a lot, so I want to be sensitive to time. And thank you for that very kind introduction. I give a little explanation for the context. I'm standing here in the dark. The good news is that I've finally been allowed back into my university office today for the first time. The bad news is there's no power. So I typically, or no electricity for the lights. And so I typically give a warning over the last 3 months that there will be little children and barking dogs in the background. So hopefully we won't have that today here on campus. So I'm very pleased to be here. When Markus and Ulman invited me to give the talk, I was especially pleased to learn that one of the themes of the series was related to the theory method dance. And I'll see if I can advance my slides here. The theory method dance, which was coined by Baltes Nesselroade, and I have a very soft spot for this idea. At the University of Virginia, I had the opportunity to train with and to work with Baltes Nesselroade, and this was one of those, for you, those of you in the Life Institute, if you've had the chance to interact with John, and I'm sure many of you have been reading his seminal works, this is one of those kind of training experiences that really is transformative. And this metaphor of the theory method dance and trying to find that right rhythm or that right balance where one isn't too far out in front of the other, which I think John's position was that one was always leading a bit too aggressively, is where you find that kind of magic for discovery. For those of you who are looking for some reading, Steve Boker and Mike Martin have a nice paper in 2018, which talks about this metaphor they use as a conversation. But this is going to be a theme that's going to run throughout the talk as I give some examples of the application of charting individual development through different methodologies of how close that matches between theory and between method. So this is the classic kind of Baltes and Nesselroade objectives for longitudinal research. And given that the topic was charting individual development, I just wanted to go back to kind of reread some of these. And I've been actually dragging around from continent to continent and coast to coast my lifespan psychology book and my multivariate analysis coursework. And I see these kind of highlighted throughout my notes, and it's always nice to revisit them. So they had identified 5 objectives for longitudinal research. Direct identification of intraindividual change, looking for intra-individual differences in those changes, interrelationships of behavioral change, and then determinants of both of those types of changes. And this is a really helpful way to kind of think about why you're conducting your longitudinal research and how you're approaching in terms of theory and method. The 3 key lessons that I took and that I'm going to share with you today that I've carried with me throughout the last 15 years in my faculty position is kind of a simplified version of this, which is the mean often represents everyone and no one, and we need methods that can get us beyond reporting on the mean or the aggregate level. Residuals are more than noise, and so this is sounds like a simple statement, but so often we throw out the residuals as noise or measurement error. And one of the meaningful kind of lessons from training at that UVA group was to look for patterns in those residuals, whether that's patterns in terms of how large the range is or a specific pattern that can be modeled in terms of oscillation. We can learn from the residuals. And then, of course, this core idea through psychology that we know and that we learn, but we often forget, which is this nomothetic and idiographic approaches. Both are needed, and the answers that we get when we apply both approaches can often differ and can often be incredibly meaningful. Also taking back to kind of training time, Catel's data box kind of never gets old in terms of thinking about this, but as we approach kind of theory, method, data, that connection, every project has been useful for me to think about what part of the data box I've been working at or approaching it from. And I would say that before meeting John and kind of learning about interindividual variability, it really was at this kind of persons by variable matrix. So spending a lot of time thinking about the representation of people, the sampling of people, a lot of sampling of variables. In psychology, we do a lot of kind of measurement, but less thought was given to the longitudinal aspects of this, other than to the importance of conducting longitudinal research, the need to kind of gather repeated measures following experimentation, for example, or in longitudinal studies, but much less thought was given to how we need to understand the timing of the process that we're researching and what type of measurement strategy over time, not just over variables and people, needs to be adopted. So with that background, I'm going to go through 3 examples, most of which is examples that I pulled from my own research. Some of them may be successful, a couple of colossal failures that have been put in there that hopefully are instructive, and at each point evaluating this kind of theory method and asking the question of whether or not they're in or out of step at this time or at the time it was conducted. So the first example is thinking about capturing the long arc of development. So many of you in the LIFE program, lifespan psychologists, are interested in development over time. Maybe that's across childhood or across childhood to adulthood or across the entire lifespan, which has been certainly the history in Berlin. And I'm going to give an example of the application of this in my own research. And I was fortunate to spend my postdoc with Terry Moffat, who had a very strong theory, a very kind of well-developed theory about how the age crime distribution could be explained. And across cultures and across time, we see this pattern where antisocial behavior, conduct problems are, well, they're relatively high preschool. Once kids hit school about age 5, they tend to socialize out of them. When they approach adolescence, we get this bump, and so we get this peak of offending and risk-taking behavior in the adolescent and young adult period, and then we get this desistance. Now, the argument that Temi made very compellingly was that developmental theory assumed that there were actually two groups mixed in this distribution. One was a life course persistent pathway in which children began acting out quite early, that they persisted across adolescence and into adulthood, and the other was more of an adolescent limited trajectory where it was a relatively uneventful childhood, and then adolescence happened, and because of kind of peer influence and what she had termed this maturity gap, antisocial behavior increased among a large portion of the population and resulted in this distribution. So really, you have this underlying distribution, you have these two groups, one which is quite small, this life force persistent, this adolescent limited, and this mixture produces this distribution. And here the mean represents everyone and no one. And growth mixture modeling provided one way to empirically test this assumption that undergirds so much of clinical practice and developmental theory. And so we did this in the Dunedin Multidisciplinary Health and Development Study. So this is a long-standing, I think the longest standing study of psychiatric illness in the world now. They finished the age 45 assessments with over 95% retention of the sample. And these are two study members. It's not a twin study, but these are male and female at birth and all the way up to age 32, which is the data that I'll be presenting today. And the idea here was whether or not at all of these assessments where we had measured antisocial behavior from 5, 8, onwards onto age 26, if we could map and if we could recover these, at least two of these subgroups from the observed data. I'll make a long story short, and all of the papers I'm going to reference today can be found on the website that I'll give at the end of the paper. So for people who are looking for kind of more in-depth information here. So we get this 4-group solution, and the 4-group solution is an interesting problem that has come up as more and more of these models have been applied. But in this case, we found this small group, this life course persistent group in the red. We found this adolescent onset, which didn't quite desist in the way that we would have thought, but it was about this right percentage. This group, which was really interesting, the childhood limited, they were indistinguishable in childhood and desisted quite rapidly and could not be distinguished from the cohort norm, which was right here by adulthood. Now, the advantage of taking the growth mixture modeling method into this specific question was, one, we had multiple measures of antisocial behavior over time, so we could actually do the measurement and variance piece of this and establish that we actually had the same ruler at every age group. We had strong prior theory, which gave us expectations about the number of groups that we should expect in the population, and here it was really kind of 3. People had observed something relative to a childhood limited group, but there hadn't been a lot of research done on this group in the past. But these 3 groups we expected, kind of the cohort norm, the adolescent onset, and life course persistent. And we had specific hypotheses about the etiology, so the childhood antecedents, and then the long-term outcomes of these groups. So in this work, we were able to connect these childhood trajectories to later lifelong problems of conduct problems to adult health, so mental health, social problems. And these, this is a lot of information, but the length of these bars are essentially effect sizes. You can see at the bottom of the screen, effect size of 0.5, effect size of 1. And this is just comparing this red group to the cohort norm across all kinds of measures that have very costly implications. And then you can start to look across groups. So here's an example. If I can get my thing to move. There we go, of the adult health of the childhood limited, and these are the males here. So we can see that not only does this group, a relatively large group, 25% of the population at age 7, look very similar to those life course persistent group, they desist quickly, and by adulthood, they're indistinguishable on many measures from the cohort norm. So that's an example where we were able to apply the growth mixture model to a longitudinal data set that had good measurement, the same measures across time, and had the type of prior theory to allow us to kind of a priori specify what we might find and test that against the data. Now, the issue is that not all of that, that's not always the case. And Dan Nagan and I wrote a review on application of group-based trajectory modeling in clinical research. In this review, we used the antisocial behavior example because there was a strong fit between theory and method. But I can tell you after teaching this method and structure-created modeling for 15 years, that there often isn't a strong kind of set of predictions regarding the number of groups, the shape of groups, the proportion of the population that should live in those groups. And so many times when we're applying these methods to longitudinal data, we're left in a more of an exploratory framework, which is fine, but that has to be specified kind of a priori as well. And of course, it's always messier than it looks. So those are those same groups charted here from 7 to age 13. And of course, when you see the publications, you see these nice lines which represent the different subgroups. But if we were to plot the actual individual data, it's much messier. And even this is cleaner than it should be because these are predicted lines. But this is often, the spaghetti plot problem, where when you first plot your data, what you end up with is kind of a black screen of lines, and it's difficult to kind of decipher. So let's take stock. The theory method, is it out of step? So without strong prior developmental theories, and Dan Bauer wrote on this very nicely, he talked about the excitement about growth mixture modeling and group-based trajectory modeling when he first encountered it, and this was going to be the solution to all kinds of problems in developmental science where we had these theories that had assumed mixtures within the population, but our models weren't quite ready to test that. Now there's been other problems. I referenced this in prior. The models will always produce groups. They will assign groups and give you a solution. It doesn't mean that they're meaningful. And it turns out that this 4-class solution is very common, right? So a high, a low, an up, and a down, referred by Ken Shearer as the cat's cradle in substance use research. So there is a large risk, I think, in this field of kind of generating kind of spurious findings or reifying groups that might not actually exist in the population. Dan and I talk about this a lot in the article. The final model selection, it's as much of kind of an art of interpretation as it is about objective model fit. So often the model fit doesn't give a clear signal of what the right answer is. And the question always is the added complexity worth it? So will you learn more from the group-based modeling approach than you would from a simpler latent growth curve model or HLM model, where you would have an intercept and a slope or some sort of parameters that specify that functional form? That's always kind of the first order question. So I think in the antisocial behavior example, there was a nice fit between theory and method. I think more broadly, the method has probably been overused, and when it is used, it can be incredibly valuable, but it'll be important to specify a priori and in an open science kind of framework way, what the specifications or expectations are around group size, group membership, etc. Okay, so the second example, this was actually inspired by Steve Boker's work. So dynamical systems analysis, trying to capture more dynamic short-term fluctuation. So this was a long-term enduring change. And the idea here was that psychological symptoms ebb and flow. They change quite rapidly. There was strong theory and kind of clinical science that the speed at which symptoms change or become dysregulated is a really important kind of concept to capture and could be predictive of impairments or more predictive impairments in absolute level. And we see this in some of the classic aging work, where it isn't so much whether or not the individual has a high or low level locus of control that predicts mortality. In that case, it's when that those views become dysregulated or start to vary quite a bit within a person. And so the idea here was to look at the variation within symptoms among a sample. This was a sample, a psychiatric sample that had been just released from a hospital following a violent incident. And it followed on Steve's model, which was following widows following a shock, so following the death of their spouse, and looking to see how long it took for them to come back to equilibrium, essentially. So trying to parameterize their oscillation and affect and symptoms. And so we did something similar here, and have high hopes for this, because the idea was that this model and the parameters that it derived mapped really well onto kind of core ideas in clinical science. And we thought that if it was predictive, that it could be hugely helpful for psychologists, psychiatrists, and clinicians, especially those that are monitoring patients intensively. So here's the basic idea. You would, we're analyzing just the residuals here. So those longer term changes across the 25 years, or 25 weeks in this case. Sorry, I'm used to working in years, not days. This is 25 weeks of assessment. And so we detrended the data. And this was also brought me back to a great University of Virginia memory. So Neelam Ram, who I believe is an affiliate of the LIFE program, we were sitting in John Nesselroade's office, and he told us to go and detrend some of the data. I think this was the data from his pregnant woman study. And we looked at each other and we thought, detrend, okay, we need to figure out what this means. And we finally came back and said, do you mean just take out, regress, like do a linear regression on it, just take out the trend? And he said, yes, go do that. So we went and did that. That was our first introduction to detrending. But here we're taking out that longer term trend, and we're looking at the residuals around that, which often would be looked at as error. And we're seeing whether or not we can fit a model that describes the frequency of oscillation in those symptoms. And then also this other parameter, eta, which gives us a sense of, it's a damping parameter, so how quickly the individual is able to bring their symptoms back to their own baseline. Right? So this isn't back to a specific level, it's not back below clinical symptoms, it's just back to their baseline. And here are some examples of the types of patterns that we're looking to capture. Here's some examples of the raw data. This is an individual who has a damping parameter, and we're able to kind of classify and recover their data. So we see the observed data here. Hopefully you can see my mouse. And then the reproduced or model predicted data here. And you get these parameters that give you the speed of oscillation, and then whether or not it's damping or amplifying over time. Here's an example of a patient who was amplifying over time. And it was interesting, these parameters, both the frequency of oscillation and whether or not the individual was amplifying in their symptoms over time, both predicted violence across the series. And we were really excited about these findings. We thought that this was going to be, not revolutionize, but really make an impact on psychiatry, on practice, on how we thought about and how we modeled symptoms. And it really, fell flat. So it was published in the American Journal of Psychiatry. I don't think was, cited much. When we gave talks, kind of ground rounds, it didn't really resonate with people. And so here was an example where theory and method were out of step. And I think out of step at this time. This was done in, I guess, a decade ago now. We were optimistic because we perceived a really good theory method fit here. We were able to recover, our R squared on the models was quite high. We were able to recover the oscillation quite well. And we could actually predict to violence. And at that point, people really weren't predicting above chance with a lot of their actuarial tools. And so we were improving upon what was traditionally out there. But I think we failed to have impact because there was this unnecessary complexity, right? So the doctors would say, kind of, what does your kind of physics model have to do with, with my patient? And there was an unrealistic data burden. So we had spent a lot of time tracking. This was a MacArthur violence risk study. So tracking patients weekly, collecting this fine-grained symptom data, but this wasn't the way that this was occurring in practice, of course. Now, I think it might be worth another try as we have different methods of tracking symptoms as digital mental health starts to scale up and we have kind of better records to apply these types of data. But this was a point at which really the kind of method and the application was out of step with where people were practically. I think there was an okay theory method fit, but in terms of the data burden and the practical implications, it wasn't the right time. Okay, so this is my last example from our work, and it's a bit longer because it's most of what we've been working on now, which is kind of real-time assessments of young people on their mobile devices through sensors, trying to really capture that intra-individual variability and to look within an individual at kind of triggers or predictors of behavior, health, and sleep, those types of things. And it's an interesting framework to apply right now of whether or not there is this kind of theory, method, data fit, because we're in a very data-rich environment. I think our methodologies for extracting these types of data are accelerating pretty rapidly, but there haven't been the kind of breakthroughs that I think we anticipated when I first got into this field. So it's an interesting time to be reflective of kind of what this means and how we might get there optimizing this. So one of the motivations for looking at the daily level for me originally was thinking about what one of my former mentors, Clyde Hertzman, had talked about was the drip, drip, drip of daily life. And that often in developmental psychology, we focus on these kind of catastrophic or big events. We're living through one now, but often in this field, it's extreme deprivation. So I know Chuck Nelson gave a fantastic talk last week, and they've done all that seminal work in Romanian orphanages, and those were extreme events, so neglect or abuse, and those are the types of things that developmental psychologists have focused on quite a bit in terms of early adversity impacting later development. And the idea, and this was nicely summarized by Clyde Hertzman and Tom Boyce, is that really social causation, or a lot of it, involves really mundane rather than exceptional exposures, right? This drip, drip, drip of daily life, these repeated and cumulative effects of kind of wearing on the person. And so we can think about the effects of, for example, living in poverty or facing daily discrimination. Those types of events, we can't isolate a single incident or a stressful life event, but these are the kind of daily hassles that someone like David Almeida would talk about, for example, and have shown in many cases that these daily hassles are often more predictive of kind of functioning or affect than our extreme or catastrophic events. And so this was one of the motivations originally to start to use mobile phones to track behaviors, to track affect, to track experiences every day in the lives of children. And we were doing it mostly in kind of high risk, high poverty neighborhoods to understand how those kind of repeated exposures to violence, to poverty, etc., impacted adolescents in their day-to-day lives. Now, this brings us to this nomothetic versus idiographic idea, and the idea that findings can be and are, often incongruent when we look at the aggregate from the individual. And one of the examples, I think this is was provided by Fisher in his article, which was at the aggregate level, you can have a correlation, for example, between those that are can type more quickly, make fewer mistakes. But when I type more quickly, I make more mistakes, right? And so you have the aggregate finding that you would get from analyzing data across people, and when you're following across an individual, you can get not only reduced effect, but an effect in the opposite direction. And this happens kind of more often than not. And so when I teach this, my intensive longitudinal course, we spend a lot of time just on this one kind of concept and really specifying beforehand, theoretically, what we'd expect to get from that R matrix. So if we look across people, what are the expectations of the associations? And then when we follow a person within time intensively, are those expectations different? And when we pre-register our hypotheses, we're pre-registering kind of on both of those levels. This is the article by Fisher that I referenced, and I really loved this article. I was actually surprised by it, that it appeared in PNAS, not because it wasn't a great article, it was just, I think, something for those of you in the Life Institute where you're so used to thinking about intra-individual variability and this lack of grouped individual generalizability is just a given, right? And here, it was really big news to a lot of people, right? That a lot of our findings in social sciences and medicine, because they're based on aggregate statistics, may be wrong, might not apply to the individual. Well, not wrong, might be wrong in terms of their application or prediction of individual behavior, right? And this is the idea behind precision medicine, et cetera. And they provide some really nice examples, right, in terms of the idea on positive and negative affect across all of these samples, where you get more variability when you follow a person across time, right, within person than you do between, right? And that's one of the first things we do when we have these types of data is partition that between versus within variation. And this was termed the kind of grouped individual generalizability. Of course, those of you in the Life Institute will think of this in terms of Peter Molinar and his new person-specific paradigm in psychology. And the idea that, you know, this excuse me, I can't talk, it's still early in the morning. It's rarely met, right? So R technique rarely equals the P technique if we go back to that data box. And this idea that the same statistical model applies to everyone is often not justified. All right, so I'll give you an example from a topic that we started to look at, and not because we were especially interested in media use, but because we were tracking young people on their phones, and we started about, I guess 12 years ago now, digital technology use exploded among adolescents, and it became part of the question of whether or not these new contexts where adolescents were spending a lot of their time were having impacts on mental health. So we came into the mobile phone as a tool for studying mental health symptoms. To us, it wasn't part of the main part of the story or part of the question. It was really just a research tool to capture this interindividual variability and to capture life as lived in a very fine-grained way. But it soon became part of the kind of research question. And there were, you know, kind of interesting findings coming out with these big data approaches. And by big data here, I mean these very large-scale studies of hundreds of thousands of adolescents where they essentially go into schools and they ask, you know, how much time do you spend on media? How much time have you spent in the last week or the last 30 days? And then asking them to report on symptoms of loneliness or depression or suicide risk. And in those surveys, they were finding correlations between the more time spent on digital devices and social media and worse mental health. And by, say, associations, I mean they were typically explaining about 1% or maybe less than 1% of the variation, but this was causing huge concern. And there's a huge debate and reanalysis of all of those data to find out kind of exactly how big that correlation was. But we had these data where we had been tracking adolescents over time and also tracking their daily digital technology use. And so we could look at this not at a between person level. And this was important to us because one of the big reports that was coming out is that young people who spend 1 to 2 days on their mobile devices look much better or much healthier than those who spend 7 or more hours per day. Okay, well, that wasn't that surprising given how different the lives of those kids are in terms of how they're structured, how their time is monitored, how they might be selecting into that. And even though they were statistically controlled in the models, it didn't seem like a strong kind of research design in terms of the types of controls they were able to enter in. So there was some residual correlation that was happening. And this residual correlation, or these small associations, were causing a lot of concern among parents and policymakers, physicians, about the potential impacts of digital technology use on individuals. So our question was one that mapped, I guess, a bit more closely onto what parents want to know, which is not necessarily what's the association at the aggregate level, but on days or when my child is using more or less digital technology, kind of what's happening to their sleep, their behavior, their cognition. I know a lot of parents are probably asking that right now, as we've seen rates of digital technology use jump rapidly, gaming for boys, more social stuff for girls, but numbers were high before COVID and are much higher now as we move through it. So these are questions that have been important to a lot of people. And here's just an example of kind of the increase in mobile phone use from 2004. We started following adolescents on their phones in about 2009, and you can see that it increased up to about 95% in 2018. And the hours spent on media screen time are really high, right? And this was before COVID, so there's about 6.4 hours for teens, that's 13 to 18-year-olds media screen time. If you go within low-income households, which is the households we're typally in, there's an average of anywhere from 1.5 to 3 more hours per day that's spent on screens, and that looks a little bit different. So there's a huge amount of time that's spent online, so important for people to understand. At the same time, there's been this increase in suicide among every age group in the United States, and especially among adolescents. And so people had turned to and looked at this increase. This second graph, this is by age and by gender. As you see the females down here, these are the adolescent males between, I believe, 15 and 24. This is the line that everyone has been really concerned about, though. These are these young girls between 2012 and 2018, a low base rate, but a steep increase. And so observers have looked at this, have looked at social media and have looked at rising suicide rates, and there's been claims made that the social media and digital technologies is actually driving this. And again, these are all aggregate comparisons, and in this case, it's just they've been looking at trend lines moving together over time, which is not a reliable way to think of anything in terms of cause and effect, but that's where we are. And so there's been these really big claims based on aggregate data regarding impacts on the population of adolescents. These big data sets, if you look at them, you get what I had mentioned before, which is this kind of Goldilocks relationship where too much is really bad, and and none at all seems to be really bad for kids who are completely disconnected, and then there's this just right moment. But it's hard to know what that means. It's again aggregate data. So we went in and we've been following using metric wire. We use EMA surveys a number of times per day. We collect information on daily digital technology use and mental health, in addition to all of the other kind of experiences of discrimination, of conflict, positive events, etc., that might be influencing adolescents' mental health. And the approach here really is to use each adolescent as their own control. So the question isn't whether or not the youth who on average spends 7 hours or 1 hour per day on their device is different, but whether an individual who spends more time today than yesterday is experiencing worse mental health consistently. So what is that coupling parameter between the digital technology use and the mental health? So we use ecological momentary assessment. We often do it for 14 days, about 3 times a day. We find with adolescents getting a quick take in the morning, after school. A lot of the schools won't allow mobile phones, so we have to time it after school to kind of recall through the day. And then a nightly survey is a kind of nice burden, measurement burden that adolescents will tolerate it, and that will give us kind of capture throughout the day. We used to do 30-day studies and found when we did those studies and dropped 14 days, we got the same answer and we're adequately powered. So we've shortened it a bit. We've now moved to using more unobtrusive measures, and so we're going for kind of 3 months monitoring in the background, but that's with very low participant burden. And so this was an embedded burst design. So this diagram shows you the 2,000 individuals. These are children attending a public school in North Carolina between the ages of 10 and 15. They were sampled to be representative of the population. Then we took a representative subsample of that after we had done the survey with the parents and the adolescents. We went into their homes, did the kind of assessments we typically do in terms of biomarkers and cognitive tests, and then started to follow them on their mobile phone or a mobile phone that we gave them. And this is the state of North Carolina, and this is the points are where they live throughout the state. And these are codes. We've geocoded them so we know a little bit about the poverty level and characteristics of their counties. And then we take these 400 adolescents and we follow them intensively using mobile phones. And we also use wearable sensors for this study as well to capture things like sleep and activity. And so on the question of the digital technology use, Mikey Jensen, who's now a professor at UNC Greensboro, analyzed these data, and the data are available for people who'd like to kind of reanalyze them. And we end up with about 13,000 observations over 5,270 days. And every way we look at this, there are no daily linkages between technology use and daily mental health. And so we just don't see these associations between the amount that adolescents are using each day or different forms of screen time and mental health. And when we do see associations, it's actually in the opposite direction. The only links that we see are adolescents report better well-being on days when they're more connected. And we found this in other research too, and it makes sense. We're not saying that that's the cause, it's more of a coupling or a selection. On days when adolescents are sending more text messages, for example, in our other work, they're reporting less loneliness, less depression, they're more connected, right? And so it's an example of a different finding when we go to the from the aggregate to the individual, and in this case, an opposite direction finding. So the issue is we've been using a pretty traditional multi-level modeling approach for this, which allows us to really partition these kind of between-person questions and then within-person questions. And it's kind of the workhorse of these types of data, and it's been a good approach. It's been a helpful approach, but I think it's time, as the data becomes more complex, our questions become more complex, to move on and to try and kind of advance our methods a little bit. Now the question is how to do that, right? This is just a summary slide. We summarize all of this research on the mobile technology use. So we brought together the large survey, so the aggregate data. We brought together our studies and others who've done daily data, and we synthesized other kind of meta-analyses just to make sure that we were compiling all the different sources of evidence. And it turns out that there are very small or inconsistent relationships across this field, which has been reported very publicly as a kind of a strong and worrisome finding. This actually ended up with my kids and their devices. They're probably on their devices right now, reporting on the New York Times in terms of this effect being more of a mirage, is what they say, and it resulted in a lot of kind of unhappy comments and messages to me about kind of not fully capturing what's going on here with our kids, and some accusations that Facebook, kind of funds my research, which isn't true. This has actually, been a pretty basic study of adolescent development using mobile phones, which just happen to intersect with digital technology. Anyway, but I don't think that the kind of book is closed on this. So our measures, even though they're daily, are certainly not perfect. There's a lot of concern that we need more objective measurements, not just reported measurements, not just at the daily level of what's happening with digital technology use. This is a very interdisciplinary field, and so there's little consensus on kind of how to measure this and how to think about kind of screen time or digital ecosystems in the same way that we've thought about kind of offline contexts. And so we've moved into kind of this more passive sensing. So this is our original study design, and we're now working with Nick Allen and his group to monitor in the background, to collect the EMA, but also to collect, so we do geocoding, we do kind of facial and motion recognition from the photos, and we do key logging. So their platform allows you to install a separate keyboard, all with the adolescent's consent, and all in terms of thinking about how to do this with them. So it's not restricted to a specific platform of what they're searching in or what they're doing, but you can get the text or examples of text from the keyboard to run through natural language processing algorithms. So this reduces that burden, and then, as I mentioned before, allows us to go for, instead of 14 days, 90 days in the background to understand questions. We had originally designed the study to go through an exam period, so a stressful life event, and the elections, but we've certainly had other stressful events happening with COVID, with civil unrest, with Black Lives Matter, and with social distancing among adolescents, which are now being quickly factored into kind of our research design. Now, there are lots of kind of companies and lots of teams that are trying to kind of solve the measurement problem, right? So that we can't just ask people how much time they spend online, that we need to do this kind of deep digital phenotyping. And there are nice examples of kind of teams and people that are doing that. One of the issues I think to keep in mind is that the measurement, even if we had the perfect measurement of people's online digital technology use, or if we in real life put a camera on individuals and followed them around and captured every single thing they saw, what we know from kind of decades of research in psychology is that it really is kind of how people interpret, how they remember, how they experience those events. And so we still need to capture, right, what people actually see, how people make sense of the information they see, how they remember that information, and how it impacts them. So just a new measure of digital phenotyping isn't going to completely solve this problem. And so this is just an example. We're working again with this EARS program, and we're starting to think about how can we move between these traditional models that we've been using, kind of multi-level model, a priori theory, pre-registered kind of expectations around what we're testing, and some machine learning algorithms that we can really make use of those back-end analytics and start to kind of explore what might be possible with the full range of the data. So in the multi-level models, what we're doing is we're pulling out and we're throwing out a lot of that residual variance, right? We're aggregating and we're reducing. And so the question is there information, is there meaningful information that can be found within all of the streaming data that we're receiving? And that's a challenge. Okay, so theory and method out of step. So I just have 2 more slides here and I will hopefully stop on time. I think in this field, methods are advancing rapidly, but there is this huge gap between the mapping of the data, the concepts, and the theory in this kind of new field, which I think is the case in many new fields. There are lack of common or agreed upon conceptual models and measures, I think because it is such an interdisciplinary space and requires collaborations across computer science, communications, child development, education, for example. Machine learning offers some advantages in terms of kind of processing these huge swaths of data, but it's often uninterpretable. And when you run the models side by side, the biggest predictors is often kind of past day behavior. And it's not clear if that's just the first kind of principal component that's being pulled out of many of these algorithms. So we need to understand exactly kind of what's happening in the black box and how those can be audited. And so we're often drowning in kind of data and models without advancing our understanding. And there is this potential, I think, for personalized measurement in real time in the streaming data. So some of the concepts bring this back to kind of John originally, as he thought about this. One idea certainly was that you could capture the same construct with very different indicators across people, right, at this latent level. And is it possible now that we have these kinds of data that we can start to get closer to that kind of conceptualization and theory? All right, so the take-home messages, the mean often represents everyone and no one, even in our multi-level models and our growth mixture models. We're still aggregating quite a bit. Novel methods, when they first come out, will often overpromise and disappoint. And the key is finding when there is this fit between theory and method and when that can be optimized for discovery. I think the future, there's reason to be optimistic. It's data rich, but better measurement alone is not going to help fully address kind of the fundamental challenges that we have around causal inference. We need to think kind of in tandem with the instrumentation or experimental and quasi-experimental designs. And lastly, charting individual development really requires us grouped individual approaches, and that goes without saying, I think, in this group. But seeing the Fisher article, which is a great article, and how much of an impact that had on people, causing them to pause about this aggregate to individual connection that hadn't been fully considered, makes it clear that it's important to remind us of that. So a big thank you to many people who participate in this, including my great students. And then again, all of our papers can be found on adaptlab.org or by emailing me. So I thank you for your time, and I will stop there.
Thank you, Candice, for a very great and rich talk. And I invite all live fellows back on the panel. And I invite all live fellows to ask the question. So fellows first. Everyone is overwhelmed by a very rich talk. Okay, so maybe then I start.
Yeah,
okay, yes, please. We cannot hear you. Wait a moment.
Okay, now I'm unmuted.
Now it works.
Okay, perfect. Candice, thank you so much. This was so interesting. And I really loved your explanation on why it is important to consider like residual or variation within person trajectories or dynamics and processes. And I think for me, it is a more general question, but you also mentioned Peter Molyneux, and he is kind of an advocate for person-specific methods in the person-specific paradigm, right? And
Yeah.
I was wondering, where are you standing on this topic, both on the methodological level, but also on the substantive level, if we, for example, are interested in adolescents who are at risk, for example, for health problems or other problems, for example, in times of Corona. What is your standing on this?
Yeah, so I think like many others, when personalized medicine kind of started to take hold, and this idea, especially now when we have the ability to capture so much data from an individual and really kind of develop prediction models that would be tailored to that individual. Now that would require working back between what we know about maybe more targeted subgroups like adolescents kind of with a certain kind of set of characteristics to kind of build those models. And you know, I was very optimistic, and I think that over the last, kind of 7 to 8 years, I've watched the field, whether that's precision medicine or ambulatory assessment, and we just haven't had those breakthroughs, right? And for the most part, adolescents actually have been left out of this because of all of the consent issues and getting those types of data from them. So we've seen some advances among adults in precision medicine and ambulatory assessment, but we've seen kind of a stagnation of research investment and findings among young people. So I think practically, I think theoretically, I would be very excited to kind of pursue that kind of individualized kind of prediction approach. And in fact, with many parents who talk to me about the digital technology question, one recommendation is to kind of monitor or kind of randomize your own child's use to look at impacts on kind of your specific child, right? In terms of how that's impacting sleep and cognition and those types of things. So I'm personally a big advocate, and I think that is kind of where the real traction is going to come in terms of interventions. But practically, I think we're just not there yet. And so the question is, how do you remove those barriers?
Mm-hmm. Mm-hmm. Thank you very much.
Question I had. Thank you for a great talk, by the way. Really interesting. I use interindividual models in my own work. I use GIME for a bunch of different things. So I have a question for you kind of about measurement, because this is something that I've been grappling with. When it comes to, I'm thinking particularly about cognition, a lot of the measures that exist weren't designed to be used to look at fluctuations between days. A lot of these cognitive measures, the kind of the reliability in their worth is based on test retest. This idea that you can give it to the person every single day and they're going to get the same score every single day. Yeah. So if we want to kind of do this intensive longitudinal thing, can we rely upon existing measures that weren't designed to be used constantly, or do we need to kind of start from scratch and psychometrically design measures intended just for this purpose?
That's a really good question. I think anyone who does kind of the EMA daily stuff as always kind of adapting, we can never just take kind of out of the box measurement because it's too long, it's too clunky, it doesn't work. And so we're either selecting measures or items, and maybe it's the more dynamic ones that we're selecting, but that decision is often, it's not as systematic as it should be, right? And the question is, Jack McHurdle had these great ideas, and people have taken it since then around kind of plan missingness in design. So if maybe you can get over some of those kind of training effects of the measurements and use the toolkits that we have. But I think we will need kind of new measurements, both for kind of engagement and for capturing the exact thing you're talking about, is that, not treating measurement, the residuals as error, but as meaningful kind of change change across day. And the tough part will be kind of designing and validating those. I think and again, this gets back to the last question, the promise is that you could have individualized items to get rid of a lot of the bias that we know exists in cognitive testing across kind of gender or race or culture, and individualized kind of measurement that would capture that latent construct in a way that, is kind of true to the theory and removes the measurement error. But that's going to require kind of really hard work in testing. But I think it's possible, right?
I hope so. Just one follow-up. That was so interesting. Thank you. Because in my own work, we do daily measurements, but there's inevitably missing data. There's inevitably people who miss days. I've never worked with adolescents. I'm going to guess that's maybe even more likely to happen. Is there kind of a successful plan to making sure, minimizing kind of the missing data or encouraging people to, what are kind of your missing rates and how do you minimize them?
Yeah, so this was a really surprising thing. When we first started doing this research, I assumed that, adolescents were never going to respond. We're going to have all these complex incentive structures to keep them engaged. And it turned out that it was pretty Pavlovian, that when the phone dinged, if we kept it short enough, they responded. And so we right out of the gate had response rates that were close to 90% of all the surveys completed, which was shocking to us, right? And they were young adolescents, they were 10 to 14, they're maybe a little more compliant. Those responses have gone down a little bit, maybe like 5 to 7% over the years. And I think we're just competing for more things on the phone. More things are kind of dinging at them. But the compliance with adolescents has actually been really good. The problem with the adolescent research field is that the parental consent, right, issue. And so many research teams kind of avoid that. It's easier to get consent for children and it's easier to do research with adults, and adolescents are a tougher group, especially adolescents who don't have caregivers who are present or willing to kind of do that. And so you get a selected group. And so it takes a lot more work to kind of get that population enlisted in these types of studies.
Thank you.
Thanks. There's another question by our life fellow Mario Naves. Mario, it's yours.
My question concerns measurement invariance. So every time you want to compare the same person over time or track it, you have to make sure that at every time point you measure the same thing. Mm-hmm. And I think it gets even more complicated when you talk about these person-focused research ideas where you say, I just want to measure the same latent construct, maybe even with different indicators for each person. So how is that possible? How do you make sure that it's the same construct measured for everybody?
Yeah, so I guess I should clarify, I don't do that. I don't use different measures for each person. I think that would be great if you could and you could get there, and for this exact reason. And so I spent most of my early career doing measurement variance on longitudinal studies and kind of throwing out half of the items because it wouldn't fit across populations. And it's interesting because 90% of the effort is getting these kind of invariant measurement frameworks, whether it's an IRT framework or an SEM framework, and then modeling it. So it's a big task. I think that would be the hope that you could do at the latent level, and there you'd have to rely on either the mapping of that process of the latent variable across time or its interrelationship with other known variables or markers, right? And so you would have to extract out a little bit to make this happen. I'm guessing John would have a better answer, or probably Neil Amram, who does a lot of this work in terms of thinking about this. But that's the appeal, though, because we know our tests, our standardized tests, are biased. I mean, we just saw at the University of California they got rid of all of them, in part because of COVID, but that conversation was going on beforehand. So maybe there is an opportunity to kind of rebuild with item-specific measurement of a latent construct in a way that creates a better and a kind of more fair measurement framework. I don't have the answer how to do that. Smart people, like people at the Life Institute, could do that, I bet.
So you say there are two paths you can go down. One is this psychometric path where you just make sure, I don't know, the factor loadings are the same over time, the intercepts are the same. And the other one would be to have a gold standard method where you know this is correct, and then I just look at the relationship to this gold standard method and make sure it's the same over time?
Yeah, so if you had a couple of items that you use to fix, right, across time and to calibrate, that might be one approach. And then the second one, exactly. So if it's a strong hypothesis about the process of how that latent construct should change across time, or how it should vary with other kind of indices to track, and maybe that requires testing within an experimental paradigm or a more tightly controlled paradigm before you let it out into the wild in the way that we do, which there's too much kind of noise to calibrate that. But you know, that seems, in terms of this kind of theory method fit, that seems like where the method would need to go to kind of fit this kind of person specific paradigm.
Thanks.
Question.
I think we can open up the discussion to the general audience. Of course, if there are more questions by the fellows, please don't be shy to ask them. So there's one question by Markus Werkle-Bergner. Markus?
Yeah, thank you, Candice, for a really rich and inspiring talk. This is an amazing project that you are working on. I was intrigued by your example of this attempt for the precision medicine, where you try to use these oscillatory models to get at personalized measures, and you mentioned that maybe the time was not right for such a nice theory methods fit. But I also thought that this might be a good metaphor for this dance between methods and theory, that for sometimes you are a bit out of the equilibrium in the methods direction, and sometimes you are a bit more out in the theory direction. And currently we have this discussion that also in psychology, but more strongly even in neuroscience, people claim we don't have enough theory, others claim we don't have the method. So I would like to push you a bit to take more stance here from your perspective as a practitioner in this field, who is trying to push the boundary what we can do with individualized measurements. What are you missing most currently? Do we have the right methods and we lack the concepts and the theory to describe it, or do you think we have the questions and the theories at hand, but we need to approach more our methods colleagues to push the boundary?
Yeah, I think we're missing the glue right now, and I think we are in a case where the kind of data and the methods, and especially with machine learning, and as we try and map that onto kind of how we understand kind of how you solve these problems, that's rapidly kind of accelerating, right? And it might be a bit out of step with kind of, maybe out of step with theory, but in some cases, you know, we have a rich, you know, we have kind of a long history of theorizing in psychology. Now, whether they're good or not is a question, but I think what we're missing is the glue. And this gets back to kind of these interdisciplinary collaborations, which aren't just bringing on someone with machine learning expertise to kind of analyze my data, but that are thinking kind of from the outset of kind of what is the measurement that's required for their models to be successful. And on our end, conceptually, how do you do the kind of theoretical conceptual integration to the constructs that we're trying to measure in this new field. And so I think the raw components are there on the theory, on the method, and on the data. And what we really miss is kind of the glue at critical periods in a project, that people are brought on too late, you know, to analyze the data after it's been collected, and we're dealing with kind of imperfect data that the machine learning people go, I can't work with this. It just doesn't, you know, work. You know, I don't have kind of enough ground truth. And so that kind of design in the front, but then also once we get into this kind of methodological space where we're drowning in data and streaming data from, you know, I experience it in our team. We have data streaming in from mobile phones, from sensors. We have people contacting us about the latest and greatest way or watch that's going to do something, and you get pulled, right? You get pulled by, oh, we could have these data, right? Wouldn't it be great to have these data, but why, right? But why? And at the end of the day, I think the most disappointing thing for me has been, with both the machine learning approaches and our standard approaches, has been the level of data reduction that goes on to make any sense of what we emerge with from the end of this, right? And I'm not entirely sure how to get to kind of the more meaningful use and integration of all of these, but it's going to take, you know, institutes that are just dedicated to doing that, or young scholars who are trained kind of at the boundaries of these disciplines to do that, I think.
Thank you very much.
Are there more questions from the fellows or from the general audience? I would have one question myself. So during your talk, I was very impressed by all this data, and of course, I think all of us being part of life, we understand very well the struggle between the person level and the group level. And I was thinking of whether we make our lives even more miserable by looking at development and maybe even teenagers, which or periods of the life that are even more or quicker changing, and where we really have a lot of development, of course, and whether some of the missing links or the difficulty to find links that may hold both on the person and on the group level is part of this so quickly changing person level. Maybe it would be easier to find this in a more stable period of life. So just one thought.
Yeah, it's interesting because I think, we want to put things in movement to understand how they work, right? And so in some ways, you look at kind of periods of rapid growth like early childhood or adolescence as a second window, or kind of transition periods. The example I gave was Steve Boker's work following a loss, or, and the idea, the kind of overarching idea there is that, you put a system in motion to understand how it works. And if we're measuring people in a relatively stable time, we might not be, that's why we bring people into the lab and put them under a bit of pressure, right? We expose them to a stressor or a stress task to expose that. I think, COVID, you're seeing this now, right? Those pressures applied where it's magnifying things, structural things and more dynamic things in society we've known that are there, but we can really see them or wanting to see them now. And so I agree with your point that we probably would find more stable relationships during more stable times. But what's the fun in that? I'm speaking, but I think there is something to kind of putting a system in motion to understanding how it works.
Yeah, I totally agree with that. And I had another question, which is maybe more focusing on the data. So for this, so you didn't find a link between the daily use of the mobile phone and mental health, but are you able also to look at the kind of use or what exactly do these children do when they use their mobile phone? And given that there are also a lot of cognitive development regarding strategic or metacognition, or maybe even the how you strategically maybe choose something to increase your mood or decrease your mood and so on. There may be some links that are easily missed when just looking at the time of usage, I guess.
Yeah, I think there are a lot of things that are easily missed, and there needs to be a lot more research in this area to kind of understand that. And I'm talking kind of narrowly about adolescent mental health. There's a whole other set of research on children's early cognition and language development and how screens might be impacting that. So we were really focused on the alarms that were being sounded about kind of social media and specifically their screen time and adolescents' mental health. So we narrowed the range to that to try and kind of explore that. We looked at different types. This is, of course, them reporting across the day the amount of time they spent. So we get time, and screen time is not a good metric. We need to understand kind of how young people are using it. The most interesting research in this area that's coming out, I think, is looking at how offline risks and especially vulnerabilities around mental health motivate searching online for mental health services and supports, motivate the types of content that young people are viewing. And so, and then there's some new longitudinal research from Canada with early adolescents and college students that shows when you go longitudinally, screen time or social media use doesn't predict later depression, but early depression predicts patterns of screen time and social media use, right? Which makes a lot of sense to me. And the effect is stronger in early adolescence as well, which seems to be kind of an important period for both social media. And so I think that the arrows, I think that there probably is an interplay there. I think the public conversation has the arrows the wrong way. And it's really about kind of early mental health influencing how children navigate and search out information online and use online tools. And there could be some reciprocal relationships after that, but the kind of directionality, if anything, goes the other way.
Yeah. Okay. I think there are no more questions for now. So thank you again for a very interesting and rich talk. And I think you, many of us felt hurt by what you said. So it was really speaking to issues that all of us deal with. So thank you again for this inspiration. And I hope that I see many of you again next week for our next lecture. Thank you.
Thank you.